Well, hello 2D, and we are going to get deep into trigonometry today. We started off with similar triangles because similar triangles lead to trigonometry. And we're going to start with right angle trigonometry, which is also called the primary trig ratios. Now, we know that every right triangle is similar to every other right triangle that has a specific angle in it because right triangles all have the same right angle to start with. And then if they have one other angle the same, then the other angle is automatically the same because of angle sum of the triangle theorem. So if I told you that this angle down here was, say, let's just pick a random number. I'm going to say that that angle down here was 50 degrees. Then it doesn't matter how big this triangle is. It will be similar to any other right triangle that has a 50-degree angle in it. And that is so useful to us that the calculator, and because similar triangles have equivalent ratios of sides, then I know what the ratio of all these sides are for every triangle that has a 50-degree angle in it. And your calculator has that information stored there. So when we're going to use the three primary trig ratios, there's a little bit of terminology that we need to get into first. And that's what we're going to learn today. We're going to learn the three primary trig ratios and how to use them to solve for angles in right triangles. So let's go through the terminology here first. When we have two right angles, or when we have a right angle triangle, we have special names for the sides. You probably already know that the long side across from the right angle is called the hypotenuse. Now, the other two names that are down here are adjacent and opposite. Now, adjacent means next to, and we always label the sides according to the angle that we're looking at. So this angle here, the side that is next to it or adjacent to it is this one. It's touching it. And the side that is opposite it is this side over here. Now, if we switch angles, like we have in this triangle over here, when I switch angles, first of all, the hypotenuse is still the hypotenuse because it's across from the right angle. But now, the side that's adjacent to this angle, that's touching this angle, is that one here. And the side that's opposite this angle down here is the opposite side. So when you switch angles in the triangle you're looking at, the opposite and the adjacent switch places. Now the ratios of these sides are all going to be the same. And by ratios, ratio inherently means division. So if I take one side in this triangle and divide it by the opposite side, or sorry, not the opposite side, but another side in the triangle, I'm going to get a unique number that is unique to every right triangle that has this particular angle in it. Now, I don't know what that angle is, but that's going to give me a way to find it because your calculator, providing you have a scientific calculator, has all those numbers stored in it. So because those divisions, those ratios of the sides are so important and that they're stored in your calculator, we give them names. So the three primary ratios mean nothing without an angle reference. Without the angle reference, you do not know which side of the triangle is opposite and which side is adjacent. The first step in trig problem solving is always to identify those sides, which is why we started with that. And we identify the angle you need to use or you have to find and then identify those sides from that angle. And here's the three primary trig ratios. Sine is the opposite divided by the hypotenuse. So if I have this triangle up here and I want to find the sine ratio, whatever number is here, I divide it by whatever number is here. And that number that I get after I make that division will be the same in every single triangle that has that size of an angle. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, we're going to abbreviate that, and you may see this up in my classroom somewhere, to SOHCAHTOA. Now, SOHCAHTOA means sine, opposite over hypotenuse, cos, adjacent over hypotenuse, tan, opposite over adjacent. Now, when I was in school, my teacher made us chant that. Sine, opposite over hypotenuse, cos, adjacent over hypotenuse, tan, opposite over adjacent. I'm not going to make you do that, but it would help you if you did. But SOHCAHTOA is pretty easy to remember, and you can always write it at the top of your page. SOHCAHTOA, that's also on the side of my classroom, at all times. See if you can locate that poster when you get into class. Now we're going to start just by stating those primary trig ratios. So here it says state the 3 primary trig ratios for the angles given in the triangle. So here's how we're going to state that. I'm going to find the sine of angle A. So if we're looking at angle A to start with, I'm going to identify the other sides. This is the opposite side. The hypotenuse is always easy, and the adjacent is the other one. So the sine of angle A, remember, sine, let's write out so, ka, toa. Sine is the O, and the O divided by the H. So O divided by the H is 3 over 5. Cos of A is ka, so I just have to write the adjacent over the hypotenuse, which is 4 over 5. And tan is opposite over adjacent, OA, so that's 3 over 4. Now you can turn those into decimals if you want, but I'm not going to bother. Okay. But this asked us to do it for the other one too. So our B, if I'm labeling the sides from B, this is opposite, this is adjacent, this is still the hypotenuse. So I'm going to do sine of B, cos of B, and tan of B using SOHCAHTOA. So sine of B is opposite over hypotenuse, so it's 4 over 5. Cos of B is adjacent over hypotenuse, so it's 3 over 5. And tan of B is opposite over adjacent, OA, which is 4 over 3. Now I want you to notice something here. Back I told you that when you switched angles, your opposite and your adjacent switched places. So when the opposite and adjacent switch places, here's what happens to our trig ratios. The sine and tan switch places. The sine of one angle is the same as the cos of the opposite angle. And the cos of one angle is the same as the side of the opposite angle. And the tan just flips over. Tan is the reciprocal of the other one when you switch angles. Okay, so that might come in handy when you're looking at it. And again, if I ask you for the ratios, you could just give them to me as a fraction, but you can change them into a decimal as well. Now, when you're doing this, your calculator needs to be in degree mode. So I've given you a little screenshot of one calculator. You're looking for something on the screen that looks like this, and it might say DEG. Now, other things that you might see in the screen that you don't want to see there are an R or a G, or rad or grad. They stand for radians and gradients, and that's just a different way to measure angles, and we're not using those ways to measure angles. So if you see those in your calculator, you need to change it out of that mode. Now, if you do not know how to change it out of that mode, you may have to ask me. All calculators are different, so I can't really show you that. But this is really important. It needs to be in degrees before you do anything. So we're going to use the calculator to find these following things. And I have this calculator here. And it's actually pretty straightforward here to find the tan of 45. And I don't know which way this calculator works. Some calculators you have to press 45 and then hit the tan button, which appears to be what this one has to do. Or you have another calculator, and here's a different calculator. Here's a different calculator, still is my last thing in there, that you would have to press the tan and then the 45. And you need to know which way your calculator works. So the tan of 45 degrees is 1. And actually, I hope that makes sense to you, because let's think about that. If we have a right angle triangle with 45 degrees down here, That means that this up here also has to be 45 degrees, right? Because they all have to add up to 180. So I need 45, 45, 90. And if these are both 45, that means that whatever this side is and whatever this side is has to be exactly the same, because this is an isosceles triangle. And tan is opposite over adjacent. And so if I divide some number by the same number, I'm always going to get 1. Now, not all of these numbers are going to work out so nicely. 45 degrees is nice for tan. It's not particularly nice for sine or cos. So they don't all work out so nicely. Most of them are pretty nasty decimals. And I'm going to show you that with a cos of 53 degrees. Let's pull this up. Cos of 53 degrees is 0.6018. Now I'm going to do it to 4 decimal places, 0.6018. If you're writing something down, if it's a ratio, one of the trig ratios, write it down to 4 decimal places. And now let's do it for sine. I'm going to use the other calculator for this one. 78. So this one I have to put the 78 in first and then hit the sine button. And that's 0.9781. So 0.9781. Now, what if I actually know what the ratio is and I want to calculate what the angle is? So I don't know what the angle is, but I know what this ratio is. So I'm going back the opposite direction. So here's how you'd have to type it into your calculator. You're going to find on your calculator this, sine to the -1. It's written usually right above the sine button. And to get to it, you have to press shift or second or something along those lines. So if you take a look at the calculator I have here, if I clear it, I need a shift. It's right up here. So if I shift that, you'll see that mine turns into sine to the -1. When you shift yours, unfortunately, hopefully, that you have a standalone calculator, and it won't have the ability to just change that to the sine to the -1. But anyway, you're going to go sine to the -1 of 0.5673. So on this calculator, I'm going to show it to you on both the types of calculator. One works backwards, one works forwards. So in this calculator, I have to type this in first. So 0.5673, and then hit the sine to the -1. On your standalone calculator, you have to go shift sine. And that looks like 34.6 degrees. 34.6 degrees. And we're going to do the same thing over here. B is going to equal tan to the -1 of 0.5673. And let's just pull up, I'm going to pull up the other calculator. And on here, this is my shift button. So you can see when I hit shift, then it turns into the -1. So on this one, I have to press it first. So what did I need to do? Tan. So tan of 0.5673. And I get 29.6 degrees. Okay, now that's if you're just given the numbers. If you're saying, I know that if I divide those two sides, I get this number, tell me what the angle is, then we can do that. But what if I have a triangle? Okay, so I've given this to you step by step. It says using trig ratios, find angles in the right triangle. So I'm going to circle the angle I want to find. So let's find angle A. Label the sides with opposite, adjacent, or hypotenuse. Well, this is the hypotenuse. This right across the triangle is the opposite, and then the one that's touching the angle that I just circled is the adjacent. Decide which two sides you will pick and then use the appropriate trig ratio. So I'm going to write out SOHCAHTOA. And if I want to find an angle, I need to use two sides that already have numbers. So if you take a look, the two sides I have numbers for are O and H. So I'm just going to go highlight the O wherever I see it, and the H wherever I see it. And you'll see that there's only one trig ratio that has both the O and the H. So that's the one we have to use. We have to use sine. So I'm going to write it out, sine of angle A. You always need an angle to go with a sine. Equals opposite over hypotenuse. So that's 3/7. And now I have to get the A by itself, and the way you do that is second function. You can't just divide by sine because sine has no, like sine's not a number, it's a function. So I have to do sine to the -1 of 3/7. Now there's a couple different ways you could type this into your calculator. I'm going to use this one. So I'm going to go shift sign, and I'm going to use my brackets and go 3 divided by 7. Now, even if this doesn't appear like this on your screen, if it just looks like 3 divided by 7, it works that way. Mine just happens to look like a fraction when I plug it in. And that tells me that it's 25.4 degrees. 25.4 degrees. Let's take a look at this other one down here. We want to find angle theta, so I'm going to circle angle theta. From angle theta, this is the opposite side, this is the adjacent side, and this is the hypotenuse. Now, we are going to write down so, ka, toa, and I know to find an angle I need two sides with numbers on it. Well, all of our sides have numbers on it. So opposite hypotenuse, opposite adjacent, I can use any of those ones. Up here, there was only one ratio that had two of them with numbers. Down here, all three of them have numbers. So we can pick whichever one we want. So I'm going to pick tan. No particular reason, I'm just going to pick tan. And I'm going to write tan equals opposite over adjacent. So tan of theta equals opposite is 5, adjacent is 12. And then to get the theta by itself, we have to use inverse tan, so tan to the -1 of 5/12. Now I'm going to use the other calculator this time, so that's this one. And if I want to do this on this calculator, I have to do 5 divided by 12 first and hit equals. And it's already shifted. On your calculator, you probably have to hit the shift button. This one's already shifted. Now I'm going to hit tan to the -1. And I get 22.6 degrees. 22.6 degrees. So always start by circling the angle you're trying to find and identifying the sides from that angle. I think that's it. It is. We're all done. Give your practice questions a try.